Good morning everyone, it's your boy Nick Mams here, and today I will be teaching you about the wonderful law of sines. Before we get into the concept of the law of sines, it is important that we review the parts of the triangle. Say we look at angle B. The sine of B is side B, opposite of it, and the cosine of B is side C, which is adjacent to it. Now for today's lesson, we will only focus on the sine of the angle. So the sine of the letter B angle would be side little b. The sine of big A would be opposite of it, which is little a. And the sine of the angle C would be the side opposite of little c. It is important that we are looking at the right sides and the proper angles in order for us to use the law of sines properly. Now displayed below the triangle is the equation for the law of sines. As you can see, the sine of the angle A divided by A is equivalent to the sine of angle B divided by the side B, which is also equals the sine of angle C divided by side C. This equation is arguably the most important part of this lesson. Therefore, it is important that we have this written down in our notes. In ionic geometry, we learned about similar triangle congruencies. These were seen by patterns such as angle angle side, angle side angle, side angle side, and side side side. In ionic geometry, we learned that angle 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 and side side angle could not be used. However, today, side side angle actually has a purpose. Get out of here, AAA. Side side angle is one of the triangle identities that we will see, which can be used for the law of sines. In addition to side side angle, we will also be using angle angle side and angle side angle for our law of sines. Side angle side and side 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 will not be used. The first types of triangles we will solve using the law of sines will be angle angle side and angle side angle triangles. Let's review what these triangles are. An angle angle side triangle is where we know two of the angles, and the side following the second angle is also known. Here we know angles A and B, which are 50 and 70 respectively, and we also know the side of A, which is 10. However, we do not know side length C, B, or angle C. In an angle side angle triangle, we know two angles, where in this case we know A and B, which are 40 and 80, and you know the side in between, which in this case is C and is 8. For the purpose of this video, I will show how to use the law of sines to solve the triangle of ABC on the angle angle side triangle. However, if you do have a question on how to use the law of sines for the angle side angle triangle, it will be demonstrated in class, and if you still have issues with it, feel free to ask questions. When the terminology solve a triangle is used, it means that you will be required to find all of the angle measurements of the triangle and the length of every side. So to begin with, it is important that we find the size of angle C. Now, as we know in a triangle, all of the angles add up to 180. So, if we were to do the total sum of 180 minus the sum of the total of angles A and B, we should get angle C. And in this case, the size of angle C is 60 degrees. Now that we have the angle measurements for each angle in our triangle, we can use the equation of the law of sines in order to find the side lengths of B and C. First, let's use the law of sines equation to find the length of side B. Since we know the values of angle A and side A, it would be smart to use that part of the law of sines equation in order to find the side of length B. The sine of A divided by the length of A should equal the sine of angle B divided by the length of side B. Once we have our equation, we begin by simple cross multiplication by multiplying sine of A by the side length of B and the sine of B by the side length of A. They will equal each other. Now, since B is the variable we wish to know the answer for, we will alienate it by dividing sine of B multiplied by A by the sine of A. Therefore, now if we were to plug in the values of our triangle into this equation, you will find the sine length of B. After you plug the numbers into the equation, it is important that you make sure your calculator is in degree mode. I actually just made this mistake myself. After you plug in the numbers, you should get an answer of 12.267, give or take some depending on the sig figs you used. The chem kids will probably make a joke now. In order to find the length of side C, you do the same exact steps as we did in sine B. However, as you can see, replace the values of B in this equation with the values that we know of C. And after computing, you should get an answer of about 11.305. These are the basic ways to use the law of sines in order to find triangles such as angle-angle-side and angle-side-angle. Let's review the steps on how to use the law of sines in order to solve an angle-angle-side and an angle-side-angle triangle. First, we found all of the angles of the triangle. We already knew two of the angles, so as we flash back, we subtracted the sum of the two angles we knew from 180 in order to get our third angle. Next, we should identify the side angle combo where you know all the values. In our situation, we knew the side length of A and the angle of A. Therefore, in the law of sines equation, these values were known. Now, it is important that you use the law of sines equation in order to solve for the side lengths of B and C. Now we will explore the use of the law of sines for a side-side angle triangle, which is also known as the ambiguous case. For side-side angle triangles, depending on the data given, you can create or solve for 0 triangles, 1 triangle, or 2 triangles, based on what data is given. In the case where there are 2 triangles, this is known as the ambiguous case. During the class presentation, we will display many more examples. However, first we shall start with an example where there is only 1 triangle formed through the given data. As of now, all we know is angle A, the side length of side A, and the side length of side B. We can use the law of sines equation in order to find the angle size of B. After cross multiplication of the law of sines equation, we are stuck with the sine of A multiplied by the length of B is equal to the sine of angle B multiplied by the length of A. We can leave the angle length of B alone by first dividing by the length of A from both sides, and then using the inverse sine of this quotient to find the angle size of B, which is 25.4 degrees. Now this problem appears like ones that we have conquered before. First, we should find the last angle length by subtracting the total of the sum of angles A and B from 180 in order to find the angle size of C. Then we can use the law of sines equation again, as shown here, and after some cross multiplication and solving, we find that the side length of C is 11.5. Now let's begin the hardest concept of this chapter. However, this really isn't that difficult. It mainly is just concepts shown before, but it's important that we pay attention now. Let's evaluate the data we were given for this problem. In this triangle, we have a side length of A of 6, a side length of B of 7, and the angle of A is 30. Being that this is the ambiguous case, 2 triangles can be created from the data given. Here's the first triangle, which can be created. Notice how the angle A is 30, the length of A is 6, and the length of B is 7. However, This is the other triangle which can be created with the data. Angle A is still 30, the length of A is 6, and B is 7. The major difference in these two is B. B in this triangle shown is obtuse, whereas B in the original triangle is acute. However, it is important to note that angle B of the triangle you can currently see and angle B of this triangle, the combination of the two is supplementary, meaning that they add up to 180. Ambiguous triangles can be solved simply by first looking at the triangle we have seen before. We can use the law of sines as previously done to find the angle of B. As previously stated, the angle B of the left triangle is supplementary with the angle B of the right triangle. In other words, B of the left plus B to the right equals 180, as stated here. Since we just gathered what the left B was, we can find that 180 minus the left B would equal the right B, which will give us 144.3 degrees for the obtuse B of the right ambiguous triangle. Now as we progress through the steps of solving this problem, we should find the last angle measurement of each triangle. In order to find the angle measurement of C, we should do 180 minus the sum of the angles we already know for each triangle. Now that we know all of the angle measurements and two of the three sides, we can use our good friend the law of sines again for each triangle in order to solve for C. After your calculations, here are the two values you should receive. 10.9 is C for the left triangle, and 1.2 is C for the right triangle. Notice how great of a difference these two are, which shows just how important it is to make sure that you are using the right law of sines and values for the correct triangle. Hopefully this video was a good introduction for you to the law of sines. Today we learned of our favorite new equation and the steps needed to perform these problems correctly. Some of you may be wondering, when will the situations occur when the triangle will have 0, 1, or 2 triangles? In the class presentation, we will go over other examples and show the exact reasoning when and why there are numerous or no solutions to problems. However, as of now, this is your boy Nick Mams rolling out.